Hey there, in this lab we're looking at energy, and we're going to be comparing two quantities to see how they relate to one another. The first quantity we're going to look at is going to be the height from which I release this Hot Wheels car from the top of that track over there. We're going to be measuring the height that we release this from with reference to this table. So the tabletop is kind of like the zero line, and we want to know how high above the tabletop am I releasing the car. That's the first quantity we're going to want to know. The other quantity we're going to record is going to be how fast the car is traveling when it reaches the bottom of the track. And we'll have to see a slow motion capture of how far it travels and in how much time in order to calculate its speed at the bottom of the track. We'll compare those two quantities. One, the height from which we release the car, to two. The other quantity, how fast it's traveling at the bottom of the ramp. You'll need to produce a graph and fit a trend line to it if you see a trend. Describe that pattern that you see and why you think it looks the way it does. Let's take a look at our setup. First we have our Hot Wheels car. It's fairly frictionless, you could say. I've attached multiple orange Hot Wheel track parts together. They're clamped up here on the top of this easel or whiteboard stand thing. And it comes down and is then taped to the table so that it doesn't move around. I've also clamped a meter stick here because we're going to want to figure out how fast the car is traveling right around here. So we'll have to end up zooming in and seeing how far the car travels, maybe 10 centimeters or 20 centimeters or so, and see how long that takes so we can figure out its speed right as it's leaving the bottom of the track right here. I have a table set up for recording some data on the whiteboard. I've also selected 7 different positions on the track that I've marked with some expo marker. These 7 positions are going to represent where I'm going to release the car from. So we'll need to measure how high each of these marks or positions is from above the height of our table. So where the table is going to be our zero line, ground level. And we care about using that as the zero line or ground level because that's where our car is going to end up. And we're looking at its speed down here. So we want to say how high was it released above this point, the surface of the table. And we'll have these 7 different positions to look at. We need to measure each of these heights that we're going to release the car from with reference to the tabletop as the zero line. And that's going to be kind of hard for me to do because I've got my track all the way over here and I can't really just put my meter stick like this and easily see where the height is. So what I've decided to do is I'm actually going to measure the release height from the floor, and I'll record that. Then I'm also going to record the height of our table itself. So if I know the table is this high, and I know that my car is being released from up here, and I know that full distance, I can subtract them, and then I'll know this distance right here, the height of the car above the table. I've created a data table for recording this right here for my 7 different release heights. The height of the table appears to be 77.6 centimeters above the ground. So I'm going to record that as the height of my table, 77.6 centimeters. We're going to end up subtracting that number from the total height the car is above the floor, and that way we'll be able to know the release height of the car just above the table. Now let's go and look at each release height. The first one appears to be 84.5 centimeters. That's from above the floor. Notice now in my table I have the release height above the floor in centimeters, it's 84.5. But the height of the table, as we said, is 77.6. So I'm going to need to subtract 77.6 from 84.5 to get the total height of the car above the table when I release it from that point I just measured. Second release height is going to be 89.0 centimeters above the floor. My third release height is 102.2 centimeters above the floor. 118.8 centimeters above the floor, is our fourth release height. 1, 2, 3, 4, 5 is up here. 131.0 centimeters is our fifth release height. 1.9. 141.9 centimeters. 141.9 centimeters is the sixth release height. 154.9. 154.9 centimeters is our seventh and final height above the floor. Again, this first column is the release height of the car above the floor. We want to know not how high the car is being released from the floor, but how high it's being released from the table. So in our second column, all of which the numbers are the same because this second column is just the height of the table, that 77.6 centimeters is going to need to be subtracted from our release height above the floor. That'll be our total release height above the table. For instance, in our first one, 84.5 centimeters. We're going to subtract the 77.6, and what we have left over is going to be 6.9, and this is still in centimeters. We want to do that for all of our rows here. Find the release height above the table. Fill in all of those rows. I'm going to indicate where the markings on the ruler is and marker on the whiteboard to make it a little easier to see. All right, I'm going to start off by releasing it from the lowest height. Here's our car. We're going to go from the lowest height. So this is the one we just did in the example table I'm making on the whiteboard. That should be only 6.9 centimeters above the surface of the table. And 3, 2, 1, go. That was our first and lowest height. Now we're going to the next highest height. So this is the release height that was 89.0 centimeters above the floor. 3, 2, 1, go. Now we're doing our next highest height. This is the height that was 102.2 centimeters above the floor. 3, 2, 1, go. Now we're doing our fourth height. This is the one that was 118.8 centimeters above the floor. 3, 2, 1, go. Now we're doing our fifth height. This is the one that was 131.0 centimeters above the floor. 1, go. Sixth height, so second highest height, this is 141.9 centimeters above the floor. Jeez, that went crazy. And then here's the seventh one, the highest height at 154.9 centimeters above the floor. 3, 2, 1, go. When we go to make our graph for this lab, we're going to put our release height on the x-axis. That is the thing we were changing. So what kind of variable is that? We'll put release height on the x-axis, and then the speed or velocity that we calculated for our car on the y-axis, and see what kind of pattern emergence. Hopefully we'll see some sort of pattern. We got 7 data points that should be in there. Maybe they'll look kind of like that, in which case you'd say, hey, that looks kind of linear or a proportional relationship. Maybe you'll see data points that kind of go like this, and maybe you say, hey, that's some sort of curvy relationship there. Or maybe you see a relationship that's curvy, but maybe in the other direction. So you'd say something like that. Using Quick Graph is a good one to use, where you can just quickly cycle through the different fits or trend lines to see what matches your data points the best. In your conclusion, be sure to talk about what shape you see on the graph. Use the proper name for that shape of graph. Describe why you think it might look the way it does. Make sure also when you're completing your graph that you have a title up there somewhere. And then watch your units. If your speed is in centimeters per second, then make your release height in centimeters. You should put the parentheses there to show what your units are. If you converted your speed or your distances into meters, so your speed would be in meters per second, then make sure your release height is in meters. That's it for this lab. Make sure you have all 4 components, the label diagram, procedure, and listed steps of what we did to execute the lab and collect data. An analysis section where you should have a data table that shows how you are getting the speed or velocity of the car for each trial. You show what heights above the table we were using. And also make sure you have a graph that you produce in your analysis section, the way that I described on the whiteboard of how to produce that graph. I recommend you use Quick Graph 5.0 because it's easy to cycle through the different trend lines and see which one fits the best. But you can use Desmos or something else if you'd like. Also, remember to have a conclusion in there. Address in the conclusion what shape you see in the graph, what you think might cause the shape of your graph to be that way. Think about what quantities are on each axis and why either you get a certain trend that's maybe linear or maybe it's curvy in one direction or the other. Take some time to think about why that might be and put that in your conclusion. That's it.